We have reached the end of module 1, and I want to do a review with you. We will take a end of module assessment here coming up in the next few days, but before we do that, it's important that we review, and we'll do that in class. But I also think it's important that we review together here on video. We are going to go over an entire review sheet, and you'll also have another one that you can practice with independently. So I'm actually going to do it with pencil and paper here. So let's take a look at what this problem set looks like, or what this review sheet looks like. All right. Hope you can read that okay. It says, Josh works at a tech shop. He organizes the showroom and lines up 20 cell phones on display. 5 rows fit on one shelf. Draw an array to show the total number of cell phones. So I always like to start by figuring out what it is they're asking me to do. And the first part here is, the first thing they want me to do is draw an array to show the total number of cell phones, total number. So we know that he has 20, and we know that there are 5 rows. So I'm going to make 5 rows, 1, 2, 3, 4, 5. And now I'm going to keep going until I get up to 20. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I'll go back and I'll make sure it didn't ask me to do anything else. He organizes in 20 cell phones, 5 on a shelf, and draw an array. So that's it. I'm done with that portion of the problem. It just asked me to write an array. Now the next part down here says, fill in the missing factor. Write a sentence telling what it represents. Let's see if we can make this a little more clear. There we go. Slightly better, I think. Fill in a missing factor. Write a sentence telling what it represents. Okay. So we had 5 rows. We had 20 total. And we had 4 in each row. That's the size of the group. It didn't ask me to label these, but I'm doing it just because it helps me remember what we did, and it helps show all of you what we're doing here. So we had 5 rows with 4 in each row for a total of 20. It also says to write a sentence telling what it represents. Now that's helpful that I wrote size of group there. So the missing factor shows the size of each group. Or you could have said something like the missing factor shows the number on each shelf. Okay. Write a related division sentence to find the total number of cell phones in each shelf. Or it doesn't say total, but we know that we started with 20. Okay, let's move this. Sorry, let's move this down a little bit so you can see a little bit better. Sorry, got a little wobbly there on you. Write a related division sentence to find the number of cell phones on each shelf. So I have 20, okay, divided by 5 rows equals 4 in each row. So again, we had 20 total things, cell phones in this case. We put 5 rows and then slash groups. And then this was 4 was the size of the group. And that is it for our first page of our review. And this is going to be very similar to the work that you do independently, both on the end of module assessment and on the independent review practice. Let's take a look at the next page here. It says, Josh stacks 18 cell phones into piles. So again, we know the total already. He puts 3 cell phones in each pile. Draw a picture to show how many piles of cell phone Josh stacked. How many piles of cell phones does he stack? So this question sort of repeats itself. It asks you both to draw a picture, and then you need to write or tell us in some way how many piles he stacked. So there are a bunch of different ways that you can draw a picture of this. I'll do two different ways for you. One is you actually could make groups of three. So you might say like 1, 2, 3, that's a pile. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I drew a picture that showed 3 cell phones in each pile, and I end up with 6 in each. Or I'm sorry, 6 piles. There are 6 piles. So that's one way you could do it. You also could draw a number bond or a tape diagram. I'll go with the number bond here. We know the total is 18. We have groups of 3. So 3, I'm going to do 3, 6, 9. Each time I add a 3, I'm counting by 3. 12, 15, and I'll go back over here for 18. And again, I have 1, 2, 3, 4, 5, 6. So again, we'll write there are 6 piles. And again, you don't need to do both of these ways. I'm just showing you that there are multiple ways that you could solve a problem like this. Let's move on to the next one. This is a little more blurry than I would have liked, but hopefully you can see it okay. Josh stacked 18 computer monitors into piles of 6. He draws a picture to show how many piles of computer monitors, draw a picture to show how many piles of computer monitors Josh stacked. How many computer monitors did he stack? So we go back up here and we say a total of 18. He puts them into piles of 6. So that's different. That's a change from our last problem. They're very similar, but this is a slight change. Last time we had a pile of 3 up here. Now we have piles of 6. Okay. So we have 18 total. We're going into piles of 6. So I'm going to start with a picture just like I did on the last one. 1, 2, 3, 4, 5, 6. That's one pile. 7, 8, 9, 10, 11, 12. 2 piles. 13, 14, 15, 16, 17, 18. So I end up with 3 piles. He made 3 piles. Now I also noticed that it said, how many computer monitors do you stack? Well, that's a little bit of a tricky question because we know that the total is 18. They already told us that. But since it asked, I'm going to write the answer. This is just sort of checking to make sure we're following directions right here, that part. Right. Just checking that we can identify the total. He stacked a total of 18 monitors. And on the last one here, I'm going to use, or I'm sorry, not on the last one, but on the other side here, I'm going to draw a different picture just to show you that there are other ways to do this problem. And in this case, I'm going to draw a number bond. So I know my total is 18. And I know that there are 6 in each pile. So I have 6 there. Label it 6. So 6, 12, 18. I make 3 groups to show that there are 6, 12, 18. If that helps you to write them in here like 6, 12, 18, as you count by that, you can do that as well. Okay, let's move on to the bottom part of this where we're going to compare the 2 things that we just did. It says, draw an array to represent his cell phones. Draw a second array to represent his computer monitors. Explain the relationship between the 2 arrays using number sentences and words. So let's understand what we need to do before we start doing it. We're going to draw an array for the cell phones. That's step 1. We're going to draw our second array to represent the computer monitors. That's step 2. And then we're going to explain using number sentences and words. That's step 3. So again, we have 3 things we need to do here. The first one I want to do is to draw an array for the cell phones. So let me label it cell phones. And if we remember back up here, let me try to move you back up. We had 6 groups of 3. So that array needs to have 6 rows with 3 in each. Let me take this back down here and go 6 rows of 3. 1, 2, 3, 4, 5, 6. And each row is going to have 3. That's step 1. Step 2 is to draw a second array that represents his computer monitors. Well, again, let's take a look up here, and that was 3 groups of 6. So that's slightly different. Computer monitors. That's different because he still has 18, but he's organizing them in a different way. And we always do the number of groups as the number of rows. So he had, in this case, 3 groups with 6 in each. So I have my 2 here. Let's get a better look at that. I have my 2 arrays here. I have a 6 times 3 equals 18 array, and I have a 3 times 6 equals 18 array. So I've now used number sentences to help me a little bit, but I could also use some words to really explain. And there are some key terms that I probably should include in here. So these 2 arrays show that 6 times 3 and 3 times 6 are both equal to 18. They are turnaround facts. I'm running out of room here, but I'll keep going. I'm not going to write this portion on here just because I've run out of room, but it would be great if you could say in this sort of problem that this shows the commutative property of multiplication. So these 2 arrays and these 2 multiplication sentences show the commutative property for multiplication, which just says that you can take 6 times 3 and turn it into 3 times 6 by flipping the factors, and that when you flip those factors into different orders, the product or the answer will still stay the same. All right, let's move on to our next section, where we're going to talk a little bit about the distributive property. All right. There we go. It's the best we're going to get in terms of clarity. It says Josh spread out laptops on the table. They are shown to the right, which is just this picture down here. 10 are black and 10 are silver. This shows how he calculated the total number of laptops. Now, it's not written on here, but since they told me that 10 are black and 10 are silver, I'm going to label that on my drawing. I'm going to look at this and say those are the black ones, and these are the silver ones. And I know that 1, 2, 3, 4, 5, 2 rows of 5 is 10 because 2 times 5 is 10, and these are the same, so there's the same number in each. So far, they haven't actually asked me to do anything. This is just giving me information. It's showing me that 2 groups of 5 plus 2 groups of 5 is the same as 4 groups of 5. We'll do more work with that down here. But so far, I'm not being asked to do anything other than just being given information for the rest of the problem. Now down here it says, use Josh's method to find out the total, explain each step with words. So his, here, let's move this back up a little bit. His method was to do 2 times 5 plus 2 times 5 is 4 times 5. Right, so we can explain that by saying, if you want to get really technical and really impress Mr. Brunel, Josh used the distributive property. Now I'm going to put in parentheses here the break apart and distribute strategy, because we've also used that term to talk about this strategy. So Josh used the distributive property or the break apart and distribute strategy to show the two colors in different of the array. There are 2 rows of 5 black and 2 rows of 5 silver. There are 4 rows of 5 all together. If you wrote something like that to this sort of question, that would be a very complete answer. Again, it says Josh used the distributive property to show the 2 colors in different parts of the array. There are 2 rows of 5 black and 2 rows of 5 silver. There are 4 rows of 5 silver altogether. If you write something like that, you're showing me that you understand the basic idea of this property is that you can take a total, 4 times 5, and break it into different sections, different multiplication sentences like 2 times 5 and 2 times 5, and understand that when you add 2 times 5 and 2 times 5, that's the same as having 4 times 5 like you had in the beginning. So that's the sort of answer that I'd be looking for on this sort of problem. Let's move on to the last one on this page. It says Josh notices that 1 row of 5 laptops are scratched. Fill in the unknowns below to describe how many are scratched and how many are not scratched. Before I even do this, because there's an array, so if they've already given me an array, I'm going to just use it. If not, I'd probably make one myself. So these are the scratched ones down here, and it's 1 row of 5. I'm going to write right on here. This is going to help me solve this part later. And over here, there are 3 rows of 5. And all together, I still have 4 rows of 5. So this is showing me the total. This is showing me the unscratched. And this is showing me the scratched. So now I can come back over here and see 4 times 5 is the total. You don't need to draw arrows on yours. I'm just showing you where these come from. 3 times 5 is the unscratched part. If you want to be super fancy, you can put the parentheses in because that's how it should look. And 1 times 5 is the scratched. Again, those arrows aren't necessary on your work. I'm just showing you that the 4 times 5 shows the whole thing. The 3 times 5 is represented here in this first portion, and the 1 times 5, the scratched ones, is represented here in the second portion of the problem. All right, let's move on to the final page of our review. All right. Now it says Josh downloads apps on the new tablets. Each tablet needs 5, oops, they messed up here, 5 apps downloaded. He downloads the apps on 10 tablets. Now they haven't asked the question yet. They've just given you information. So there's nothing you have to do yet. Again, let's read it one more time so we understand what's happening, but know that we don't have to do anything yet. So Josh downloads apps on the new tablets. Each tablet needs 5 apps downloaded. He downloads apps on 10 tablets. So 10 tablets, each of them are getting 5 apps. This first part says, draw a picture and write a multiplication sentence to find the total number of apps he installed on the 10 tablets. So again, we had 10 tablets, and he's going to do 5 on each. So I'm going to do a tape diagram. and I know the number of groups, and I know the size of the groups. I don't know the total yet, so I'm going to leave the total down here blank for now. But I can start filling in how many sections or how many units I have here on my tape diagram. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I need to add one more on the end here. I didn't get this quite right, but there we go. So I have 10 sections. Each of them are worth 5. So again, these are the 10 tablets. The boxes in here show each one is worth a tablet, and there are going to be 5 apps put on each tablet. So like 5 apps on the first one, 5 apps on the second one, 5 apps on the third one, and so on until you're done with all of them. So we can count by 5s 10 times, or we could write a multiplication sentence. We have 10 groups or 10 tablets times 5 apps on each. And we know that we can, when we multiply by 10, we're just going to add the 0 onto the back of this factor. So we'll turn that 5 into a 50. And so there are 50 apps. And we've completed everything we need to for that portion of the problem. We can move on to the next section, which says Josh used the equation 10 equals blank divided by 5 to figure out how many apps he needs. Is his method correct? Why or why not? So there's 2 parts here. First, you have to fill in this blank. That's step 1. And then you have to explain why his method is either correct or incorrect. And that doesn't just mean say yes or no, but you actually have to give a reason in writing and with numbers. Or with numbers, you can do either or. So in this case, we know that 50 or 10 times 5 equals 50 is in the same fact family as some division sentences. So I could also have written this, I'll do it up here, as 50 divided by 5 equals 10, right? That's how we usually write it. But notice that this 50 divided by 5 equals 10 is the same thing as this. The answer is just flipped. Like the answer is just on the left side as opposed to the right. So we could just put the 50 over here. Notice it still says 50 divided by 5 equals 10. The answer, the quotient is just on the left as opposed to on the right. And don't let that throw you off. It still means the same thing. So now we get on to the crucial part of this question, which says, is his method correct? Why or why not? Well, I would argue that yes, his method is correct because he's used 2 facts from the same fact family to solve. You don't need to solve with multiplication because a division sentence from the same fact family can just as easily solve this problem. And that's what I would write and say, his method is correct. This fact or this equation is in the same fact family as 10 times 5 equals 50. You can solve with either one and get the same answers. Okay. Now, the only thing we need to know about this is we did need to use our diagram here to figure out that we had 50 total before we could do the division sentence, right? We couldn't have done that until we had figured out our total. But once we knew the total, we could certainly use division to model that problem with an equation. And last 2 sections here. It says, if he had credit to purchase and install 80 apps, how many credits were left after he downloaded the apps on the 10 tablets? So we know that he's done 50. I'm just taking a few notes here. He has enough credits or money for 80. So this is just a finding the difference situation. This just says that he had enough to do 80. He only did 50, so we're going to take away. We're going to find the difference between what he did and what he could have done. And whenever you're finding difference, you're using subtraction. And then we can easily solve that 80 minus 50 is 30. So he has 30 credits remaining. Right? He could put 30 more apps onto tablets if he wanted to. And the last part here says Josh boxes 10 tablets. Each box fits 2. Draw a picture and write a number sentence to show how many boxes he fills. So he has a total of 10 tablets. I'm going to do the number sentence first. 10 tablets. He's putting them into boxes of 2. And we need to figure out how many boxes he has. Okay. Now is where I'm going to fill that back in a minute, but let's draw my picture first. I'm going to use a number bond. I know that he has 10 total tablets. And then I'm going to put them in boxes of 2 and count how many boxes I need. So 2, 4, 6, 8, 10. So there's 2 in that box, 2 in that box, 2 in that box, 2 in that box, and finally 2 in that box. And there are 1, 2, 3, 4, 5 boxes. I'm going to write a sentence with that because we know part of our read to write process is to write a sentence with these. And I will say he uses 5 boxes. And that is it for our review. You will notice that there is some fact fluency work on these, ideally timed. In this case, it says 100 seconds. So that's like a minute and 40 seconds. That is a minute and 40 seconds. And this is important practice too, just like we've been practicing in class to do this as well. But I'm not going to go through that with you here. I'll let you do that independently. If you have any questions, this is the exact sheet that we're going to do together in class. Obviously, I would give you a chance to do it on your own in class. And then after you've had a chance to do it on your own, you should watch the video if you have any questions and after we reviewed it. But you'll also get a very similar sheet to practice for homework, which is likely when you're doing watching this video. So if you have any questions, access the video and I'm sure it will help you with the similar problems on the homework. And then these problems are, again, very similar to the problems that you will experience on our end of module 1 assessment. So if you have any questions between the review that we do in class, this video, or the homework, please let me know and I will do my best to answer them for you.